Hello everyone, how are you all doing? I hope you all are good. So today here we are meeting again with a new video. Recently I have completed Nevis Work series. There is a complete course on Nevis Work that is available. So today we are going to start with a video on interlock block. Okay, so there are interlock blocks which we use mostly for pavements. So what if we want to model that block in Revit and we want to place it, we want to model it in such a way wherein how, uh, no matter how our topography is undulated, it should adapt whatever surface we are providing. Okay, so that is going to be a parametric family wherein no matter how much undulations are there on the surface, but the interlock block will adapt to that surface, and you will be able to achieve those undulations. So let's jump onto Revit, and here what I will be doing is I will take this metric pattern based template for this one. So here this is the generic model pattern based template. So here the size of our interlock block is 400 by 200, and there will be a grout of there will be a grout of 5 mm in between one interlock to the other. So this is going to be 400 by 200. Okay. So yes, our size is ready. Now, a lot of work is remaining here. We have to create the interlock block in such a manner that it should adapt whatever undulations are there on the surface. So the very first thing that we will do is we will first take this point and we'll make sure that this is set to draw on face, and we will simply place these points on these lines here. Okay, so we have placed our points on the reference lines. Now it's time to restrict them. So I will say that the measurement type has to be segment length, and from the end it should be at a distance of 2.5 mm. Okay, now you can see that there is a gap of 2.5 mm that is created, and here as well we will do the same thing. Segment length, so keep this as 2.5 mm. All right. Okay, so let us first we'll select all the points and we'll change the measurement type to segment length. If I do yes, here what we'll do is segment length. Okay, this is done. Now next is this one. So beginning is 2.5. I will keep this as 2.5 now, and then it's the next one over here. So again, keep this also as 2.5, and then let us see where it goes. Okay, so there is the overlap. So what we'll do is we'll change this to end, and we'll keep this also as 2.5. All right. So here this segment length has to be also 2.5. Okay, and then here first we'll check what segment length, measurement from parameter that we have given as beginning. So this has to be end, and from end 2.5. So now this is the last set of points that is remaining. So if we give this as 2.5, where exactly it goes? Okay, that is beginning, so this will be end, and here 2.5. So what we have done is we have restricted our points at a distance of 2.5 mm from the major reference plane, and the reason why we have done is we have done it to make sure that we are able to achieve that grout distance between the two interlock. So now it's time to draw a line here. I mean, the reference lines will meet both the points on the opposite side of the reference plane, and here as well, and then here also. So now what we are doing is we are making a skeleton for our interblock to rest on. So now I have got here four intersection points, and I will place my first point here, and then here. Okay, all right, and then one point will be here. Okay, so this is the last point. So once I do that, I need now my bottom skeleton is ready, wherein this will be my length, this will be my width, but on top as well I have to provide the same skeleton for the interlock that I have provided at the bottom. So for doing that, what I will do is first I will set the reference plane over here, and then I will place the point on top of this. I will get the note saying that the points overlap, but no worries, this point will not be resting here, this point will be going on top. So offset we will give as height, and this height what we will do is we will keep as 80. This height we will keep as 80. Okay, so once we do that, it goes on top. Okay, so same thing, what we will do is we will do it here, and this also. First, before doing that, we will set a plane, and then here we are keeping the point. So this point again, we will do the same thing. We will move this point on top. So there's a point on top. Now defining the reference plane again on top of this, and here just make sure that you accept that warning, and then again here we will associate this with the height. So 3 points done. Now there is this last point remaining. Before that, we know the drill, setting up the reference point. Okay, once we do that, this point, and it will go on top. So what we have done is our 4 points are resting on top at an elevation of 80. Okay, so now I have selected the 2 points, and let me just select these 2 points, and then this option I am selecting to draw a line in between the 2 points. Okay, this is also done, and then this is remaining. Okay, let me select this again. Oh, right. Okay, so here again there was a warning, just avoid that. Okay, this is done. So now we'll select these 4 lines here, and we will tell Revit that this has to be a reference line. Okay, we have done that. Now what I will be drawing is I will draw a reference line in a chain form on bottom reference points. Only for that, make sure that this chain is enabled. As you do that, you can start placing these points. Okay. Well, so wait, how many more points remaining? One last reference plane is remaining. So here we have covered everything. and when I select this, I get the confirmation that the 4 lines are selected. Next, I'll select the 4 lines on top. I will go and create a solid form for my interblock. So my interblock is ready now, and this interblock will adapt any undulations that will come on its way. So here we will open a new project. I will open an architectural template, and let me model the massing here. So this is a mass 1, we will give that as a name, and here let me draw a square floor, and we will select all the lines. We will say Revit that we need a solid surface. Okay, so here, as you can see, the top surface, we will consider that this as a topo surface, or this as some sort of ground with undulations. So now first what we have to do is we have to load this family into the project. Okay, once we do that, you come here, select your pattern to family 1. Yes, our family is in line, and this looks beautiful. Okay, this looks fine. We'll just see from the top, everything is in line. Okay, next thing what we will do is we will create undulations on the surface. To create the undulations, I will move this vertices on top, and you will see that the profile will adapt to the undulation. Okay, so now I will move this edge on top, and let's see what happens. Okay, so no matter how the ground is, these the family that we have created, it will adapt to it. Let us bring this vertices down. So this is how beautiful the conceptual modeling in Revit is. You can play around with anything. So if you try to make such type of family in the normal family environment, it is impossible. It is impossible. See, no matter how the great undulation is, it will adapt to it, and your family will not break at all. Okay, so this type of modeling is required for landscape modeling in most of the places where there is an interlock block and there is a grout of some distance, and this isn't possible to model in other family template. There is another way to create this by Revit parts method. That option again is a manual method. Here, this is an automated way. Just like create a family, a parametric family. No matter how you change the vertices or else the edges of your plane, your family will adapt to it. Okay, so thank you so much, learners, for joining in. I hope this video was very useful to you. So as always, let us rise and sign together. Thank you so much.